Pieces of decommissioned industrial equipment, parts of vehicles that probably don't longer exist, tools and materials in the production of which enormous amounts of energy were spent. Energy that probably was cheaper at that time than it is now. It is therefore justified to search through this scrapyard here and see if some of this equipment can be repaired, reused or repurposed before we think about spending yet another huge amount of energy in the making of entirely new things. So follow me along then as I search through these scrapyards, looking for tools and parts that deserve a new lease on life and retrieve them to my workshop. So let's see then what we can find here today. What do we have here? Looks like some kind of motor-powered chain hoist, in this case for 1000 kilograms. And here's another one, but with the motor missing. Pretty beat up stuff. Here, an old air compressor. And as you may know, I really like working on those. But the pulley and piston is broken. The tank is probably heavily corroded as well. And I think I'll find a better compressor in time. But what is that? Probably the biggest submersible pump I have ever seen. This one is definitely a keeper. A big twin piston compressor pump. It looked impressive at first, but it seems to be a budget version and is also in really bad shape. And what do we have here though? Some vices and a huge pulley that the scrapyard owner deemed too valuable for the trash, and that's why he put that here. And I'm buying 2 of these vices and the pulley as well. And a machine that I can't clearly identify. Do you know what this is? But let's leave the scrapyard for now for another place where I sometimes find good stuff. I'm at a small flea market, especially for tools, and here I have found an assortment of rare old drill bits that I will also restore in this video. Let's get back to the workshop then. Again, we will begin with something easy and then progress to much more challenging repairs in this video. I start by inspecting the drill bits. They come in various forms and diameters, but they can also be put into 2 groups going by the shape of their shafts. They all have these tapered rectangular tips, but some of them are square while others are flat. And it's typical that they were lumped together with those hand drills over at the flea market, because even though these hand drills are old, they are already too modern for these drill bits, which were used before chucks were really a thing with hand drills. You'll see what I mean in just a minute. And I begin by putting all the drill bits into citric acid and I leave them in there overnight. The chemical reaction leaves a yellow color and a distinct smell. If you want to know more about that, I recommend you watch my video about chemical rust removal methods, and you can find that down in the video description. The citric acid can help a great deal in removing rust, but it is still necessary here to clean and polish the surfaces manually to get a nice finish. I remove remaining dirt and rust and oil every drill bit individually. And while doing this, I find many punch marks of old German manufacturers. Johann Peter Ahn's city of Remscheid, later known as Matador. Pharmak, city of Remscheid. And some jewels just ensure you that they are German. But again, we find at least 3 different companies that were only a few kilometers apart from each other, centered around the cities of Remscheid and Wuppertal, center of the German toolmaking industry. And I take my time in cleaning and slightly oiling every last drill bit, and I can recommend this as a form of meditation. And while these drill bits can still be found here and there, an assortment of this size and in this condition is very rare. But what kind of chuck are these drill bits supposed to be used in then? Well, here are 3 antique hand drills that I simply found in my workshop when I moved in here, and they are exactly what we need. As you can see, they don't have a chuck at all. It's really just a slot with a screw. But do these drills still work? Well, if the apocalypse comes, I might still die from 100 different things, but at least now I can drill holes without the need for electric energy. So let's take a look at that submersible pump then. This pump weighs over 40 kilograms and is professional equipment used by the firefighters. It was made by a German company called Must, and you don't want to know what these pumps cost. On the nameplate it says that the pump has a flow rate of 800 liters per minute, which is more than 5 times of the pump I repaired in an earlier episode. It comes with a long 3-phase power cable and a motor breaker that is integrated into the plug. The rotor looks a little rusty, but other than that, this broken cable guard is the only fault I can find so far. In order to replace the guard and to see if there is any internal damage, I unscrew the 4 Allen screws that hold the top of the pump on its body. We can see that there are 2 O-rings and that water is leaked into the outer compartment. I think that's not because of the O-ring but because of the screws. They are not perfectly watertight. I can find no traces of humidity inside the inner ring though. As I read on the manufacturer's website, the motor itself is completely waterproof. I temporarily removed the power cable, ordered a new cable guard, and replaced it and put the pump back together. Since I couldn't find any other problems, I devised a plan to test if the pump works in principle. Since I have no pond or any larger body of water, I'm now filling this 90-liter bucket with water. But as you can see, the pump sucks that dry in a heartbeat. I will do further testing to see if the pump is really staying dry inside later on, but for now I consider it a working unit. Let's head on to a much more challenging job then. Let's repair this big vise then. If you've been following this video series for a while, you've maybe seen this vise before. I had glanced at it a few times before when I visited this particular scrapyard in the past, but I had dismissed it as too much hassle. But I'm actually fascinated by repairing cast iron parts, and I want to develop my skills in brazing and in using the oxyacetylene torch in general, and that's why I bought this vise after all. Let's inspect the damage. The screw box holding the sliding jaw is loose, with 2 bolts missing and 1 broken off. The cast iron guide rail for the sliding jaw has broken off and is missing. Someone repaired it with a steel plate at some point in the past though. The sliding jaw is also stuck, maybe even due to that earlier repair job. And after buying this vise I did some research on the internet and found pictures of this make and model, RB number 6, and similar models by that same manufacturer. Some in better shape and some with similar problems. Here you can see what that box looks like when it's properly bolted in place. And here you can see the original cast iron guide rail, and here another example of a broken and missing guide rail. But let's start the repair then. I start by unscrewing the box. Now I'm trying to force the slide out of the vise's body. I don't want to do any more harm though, and that's why I'm using a plastic hammer, and I'm successful in opening the jaws at least a little bit. But the hammer is too short to go any further than this. I try several items until I end up using some old copper pipes to beat the slide out of there. After moving it for around 10 centimeters, I realized that it is not the body but the guide rail that causes the friction. At some point someone has riveted a bent steel plate to the bottom of the vise in order to form a new guide rail, instead of the old cast iron one. I'm not saying that that is a bad repair, but after the years the new rail might have bent or rusted away to a degree where it makes it impossible to use the vise. It has to go. I'm using an angle grinder with a cutoff wheel in order to remove the rivet heads. Then a punch mark is used to beat the rivets out of there. With the old makeshift guide coming off, the sliding jaw can now easily be pulled out of the body. In the next step, the sliding jaw is wire wheeled with a big angle grinder. This is not yet about a perfect finish, but more about removing thick rust and old grease in order to inspect the part for more possible damages, but luckily I don't find anything too serious. Now I focus on the broken body of the vise. On the bottom we find lots of rust, but cast iron is actually quite resilient to rusting, and the loose corrosion we find here seems to be from the steel plate that was riveted to it. The remnants of the rivets are drilled out and punched out. Now the body is wire wheeled and I start with the crack itself. The gaping hole in there might well be a blowhole, in German Lunker, that was created during the original casting process. It might also be a drill hole that is a remnant of yet another earlier repair attempt. The fact that I found another vise with the same fault online shows that this might just be a weak spot of this particular model. The backside of the body is wire wheeled as well. I'm trying to use this silicone spray to clean the drill holes that once held the bolts holding the box, and as luck would have it, these ordinary M8 bolts just fit inside. Unfortunately, the only original bolt seems to have broken off at one point. I wouldn't have thought that this would work, but I managed to just get it out of there with some pliers. Some wire wheeling continues, and I even use sandblasting to remove dirt and rust. Now I will start to prepare the crack for brazing. A grinder wheel is used to remove some material and to get a nice and even surface. Here, a custom-made piece of steel will be brazed to the cast iron body. You will understand in just a few minutes. But first, the box is also wire wheeled. Here the pipe vise for round workpieces comes in handy. I repaired it in an earlier Repair-A-Thon. By the way, you can find all earlier episodes of this series down in the video description. But before the brazing can begin, a new guide rail attachment must be made from steel. A few pieces of leftover flat stock are cut with an angle grinder, and at least some of the surfaces are ground off. In the meantime, body, sliding jaw and box have been put back together, with the jaws aligned as well as possible. The flat stock pieces are carefully placed onto the vise and aligned, before they are TIG welded together. Now 2 4mm holes are drilled into the stock. I mark the spots on the vise and drill 2 small holes into the cast as well. And now 2 M4 threads are hand cut into the vise body. And now 2 bolts are screwed in there in order to hold the attachment down. The purpose is not to withstand any larger amount of force. They are simply there to keep the attachment aligned until the part is thoroughly braced in place. If the guide rail were to slip off during that process, the vise could end up unusable with a jammed jaw like before. And now 2 thick pieces of flat stock are used to reinforce the new guide rail attachment. In order to brace the parts together, the workpiece needs to be preheated to several hundred degrees Celsius. Since I don't have an oven that size, I employ this self-made fire bowl that I made from a shower tub in the last episode, and I use a fire to heat up the vise. While the fire is burning, let me explain what brazing is and why I'm not simply welding the pieces together. Cast iron is very hard to weld or braze. In order to weld it, you can use stick welding with electrodes containing nickel. However, the workpiece needs to be preheated and cooled down slowly after the welding, or the weld will simply crack open. Furthermore, welding is very hot and can weaken the cast iron. Brazing, also called hard soldering or in German Hartlöten, is different from welding because the temperature is only hot enough to melt the solder, but not the workpiece. It is thus less invasive than welding. Brazing is like soldering, but always hotter than at least 450 degrees Celsius. Here we are brazing with brass filler, which melts at over 900 degrees Celsius. After the brazing is finished, the vise is placed back into the tub in order to cool down slowly over many hours. The next morning, I use a slag hammer and a wire brush to clean the seams. Up here I certainly used too much brass, but the bond looks good enough. The brace on the side looks better than what I had expected. Keep in mind, I have never brazed on such a large workpiece before. It takes experience to know what nozzle to use and how to apply the right amount of heat, etc. Considering that, I'm more than happy. Now the guide is completed by quickly TIG welding another piece of flat steel onto the attachment. I wanted to wait with this till the very end to make sure that the sliding jaw can travel with ease and that there would be no jamming in the process. And because I seemingly just can't get enough of it, there is now more wire wheeling, and finally a coat of oil is applied to the vise. Some of you might wonder why I rarely apply paint to my items here. The answer is easy. I think there is no color better than raw cast, and here in my shop I just don't have any problems with humidity. But will the brace hold? Well, only time will tell, and we will sure use this vise in the future since I really have started to like it, and you can be sure that it will pop up again in future episodes being used as a vise in my shop. Phew, that was really a demanding repair, and I do feel a little exhausted. After that, I will now show you one more item, but I'll make it quick since the repairs on it were really not that spectacular. From the same spot where I found that big vise, I also brought this smaller unit here. I found it interesting because of its unusual shape. It also seems to be welded together from steel and cast iron parts, which I haven't seen before. This vise really didn't have any real damages. I simply removed the old paint and rust, but this time also employing chemical paint stripper. It works well, but it has a pretty nasty smell, and you will end up with the mixture of often toxic old paint and the remains of the paint stripper, which is maybe not that easy to get rid of, plus this stuff is kinda expensive. But after I had washed that off, I again proceeded by cleaning and oiling the vise, and for relatively little work we sure have a nice mid-sized kinda historic vise here. So as always, I hope that you enjoyed this episode, that you like this concept, and if you liked the video and want to see more, then please give the video a like, giving me a clear signal to go full steam ahead with the production of more videos like this. And if you want to support my work here, then maybe consider visiting my Patreon under patreon.com/tpai, and you can also find a donation link under this video. See you soon, guys.